Hello friends, and today we are going to talk about tree data structure. Tree is one of the most frequently asked data structure and it is very important from product based companies interview perspective. Now let us talk about binary trees. So binary trees is made up of two different ones. One is tree. So tree would be a cyclic graph, something which is composing of node and vertices, but there is no cycle present. Another is binary, that means each node will be having at max two different nodes as children. The binary tree is a recursive data structure. It means that whatever is a subpart of binary tree will also be a binary tree. Right. Now this is our first lecture on tree. I'll try to cover important topics of binary tree in coming 3 and 4 lectures. So let us start from the very basic topic on binary trees, and that is traversal. What is traversal? Traversal is to go over tree node by node. For example, if you have a tree something like this, okay, and then you have 1 2 3 4 5 6 and 7, right? This you can traverse in three different type. One is in order. In order means first you will go towards left subpart, then you will visit the root, and then you will visit the right subpart. In pre-order you will visit the root first, and then you will go towards left and then towards right. In post-order you will first visit the left subpart, then right subpart, and then you will visit the root. So if I take the in-order traversal of this particular tree, what it will do, it will go over the left subpart, which is this one, and then within the left subpart again we will go towards left first, which is 4, and then we'll go towards root, which is 2, and then we'll go towards right, that is 5. Then we will come back to the root, that is 1, and then we will visit the right subpart. In the right subpart also we will go to left first, and then we will go to root, and then we will go to right. So this will be the in order traversal for this particular binary tree. In the same manner, if we go for pre-order traversal, first we will visit the root, then we will visit the left. In the left only, we will visit the root first, then we will visit the left, and then we will visit the right. Now coming to the right part, we will visit its root first, and then its left, and then its right. So this is its pre-order traversal. Similarly, we can find post-order traversal also. In post-order traversal, first we will visit the left subpart. In the left subpart again we will visit the left node, that is 4. Then we will go towards right, and then we'll go towards root, and then we go to the right subpart. In the right subpart we go to left first, and then right first, and then its root, and in the end we will go to the root of whole tree, and that is 1. These are recursive ways of traversal. Why they are recursive? Because here if we look at the pseudocode of in-order traversal, pre-order traversal, and post-order traversal, we have defined one function, and then each time when we are going to either left subpart or right subpart, we are calling the same function again and again. Same is the case with pre-order. The pre-order is being called again and again for left and right subpart, and is the case with post-order. Using recursion to traverse a tree is very trivial and obvious solution, because the recursion stack is taking care of everything. But what would be more interesting is if we try to make the stack by on our own. In that way we will be able to have our control over the memory allocation, right? So now we understand the iterative way of traversing a tree with the help of stacks, and let's see how that works with the help of its pseudocode. So first we look at pre-order traversal. So if we take the tree, same tree again, and we take 5, then we take 6, and we take 7 here. Now here it is saying that we take an empty stack. Say we are taking a stack here. The name of its stack is node stack, and then we push the root to the stack. What is root here? Root is this, and then we have pushed the root here. Now it is saying while node stack is not empty, we have checked that yes, it is not empty. We pop up the item top from the stack, which is 1, right? We have popped it and we have printed it. Yes, we have printed it. Then we are taking its right child and we are taking its left child. So the right child and the left child, right is here and left is here. Now again we go back to the same condition and we check that if node stack is empty or not. It is not empty, hence we pop 2 here, right, and we check for its right and left child, right and left child, right. Again we go to the same condition and we pop 4, and for 4 we see that there is no right or left child, hence we just pop it. Same for the case for 5, and this time we pop 3. For 3 we push its right child and then we push its left child, right, and then we pop the left and right child again, right. If you look at the pre-order traversal, 1 2 4 5 3 7 6, 1 2 4 5 3, okay, here we did a mistake and it will come 7 here first, which is right this, and then it's like it will be something like 6 and 7. So here we look at that yes, the pre-order traversal is working like this. Now if I write a pseudocode here, the pseudocode would look something like this. We take a stack and then we make the stack will be our node stack, and then we see if node stack is not empty. In that case we find our node, which is temp, is equal to node stack dot top, and then we check if temp has a left. First we check if temp has a right. Yes, if it is there, if it is not null, then we push that child into node stack, then we check if temp has a left, then we push the same into our stack, right, and the same thing continues, and this is how we do our pre-order traversal. Now let's move towards in-order traversal and try to do the same with the help of a stack, taking the same example. Now here it is saying that we take an empty stack S, okay, let's say an empty stack S, and then we initialize current node as root. This is current node, we have initialized it, and then we push the current node to S, that is 1, and then set current is equal to current dot left, right, and then what we are doing, we are just pushing the same thing again and again. That means we are pushing 2, then we are going to its left, that is 4. Now there is no left, right, so we come here, then we check if current is not null and the stack is not empty. So current is null but stack is not empty, hence we go inside the stack and we pop 1, and then we print it, and then we go towards it. Oh sorry, we need to pop 4 first, right, we have popped because this is what is on the top, and then we check if it is a right. No, it doesn't have a right, hence we just come back, we come back to 2, and on 2 we pop it, and then we check if it is a right. Yes, it is a right, so we have put 5 here. Now for the 5 also we move back to the step 3. That means for its also we will try to check its left child, and there is no left child present, hence we just pop it and we put it here. Then we move towards our root, which is called all these iterations, and we put it here, right? And this time when we pop it, we go towards its right, and for the right also when we put it here, we go towards its left with the help of this line number 3, and we put all the iterations here only. And so if it put 6 also here and then 7 inside it, right? In the same way, first 6 will be popped, and then 3 will be popped, and then 7 will be popped, and this is the same traversal which we have seen here: 4 2 5 1 6 3 7, 4 2 5 1 6 3 7, 4 2 5 1 6 3 7. It is here, right? Now let's move towards writing a pseudocode for it, and that will make it more clear, right? So first we will take a stack. Let's say stack is S, and then we initialize current as root, right? And then we go towards the while condition, which is here, this condition, while current is not null, because it is saying we need to check, and then we also need to check if stack is not empty, right? So stack is not empty. This is something like this. Right, we need to check for these two conditions. Now what we will do, we will check for all the left child of current, and each time we will keep pushing them in stack. Current dot left, right? Is it getting clear? Right, and when current becomes null, then we pop it again, right? And then we print it. So we print current dot val, whatever is the value of it, and then we move current to its right. This is how it works. So simple, this is same. We are making a stack, initializing the root with the current. We are checking if the current is not null or the stack is not empty. Okay, this condition will help when you will go towards right child. Okay, and then if current is not null, for all the left subchilds, left nodes, you will put them in the stack, right? And then when you reaches towards the end of the node, you pop it, and then you try to go towards its right. So the idea is to start from the root, go towards extreme left, and we reaches extreme left, then you go towards its right also, and then you go in the extreme left of that also, and then this whole thing is traverse. Then you come back, and then you move towards the upper one, and for that also you do the same thing, and then you come till the root, and then you go towards its right. So it is something like that. Now let's move towards the third traversal, that is post order traversal, in which what we do is we do left first, then right first, and then root first, and this one will be done a little bit differently. So I have made the same binary tree again, Here the pseudocode says that we need to have two stacks to make a post-order traversal. So let's have two different stacks, the stack 1 and stack 2. And the first line says that we need to push the root to the stack. So we push root to the first stack, and then we check if the first stack is not empty. If it is not empty, we take out the top element to the second stack, right? And we push the child of the popped element back to the first stack, that is 2 and 3. Right, now again we pop an element 3. For 3 we pushes its child back, left child first, right child first, and then we again make the same thing, which is 7 and then 6, right? And then we come back to 2, we put 2 here. For 2 which has been moved to the second stack, we take its child, which is 5 and 4, and we put them here, right? Now we take contents of second stack and we print them, 4 5 2 6 7 3 1. This is our post order traversal, right? Did you get that we are using two different stacks? First we are pushing some element to the first stack, we are popping them, putting them into the second stack, we are putting left and right child of popped element back to the first stack, and then we reiterating same thing again and again. This is how we are going to do the post order traversal. Now let's look at its pseudocode. We will be having two different stacks, right? Stack 1 and stack 2. And then what we'll do, we will push the root into the first stack, right? And then we will check while our stack 1 is not empty. What we'll do, we will pop out top of it, right? And we push that to the second stack. And what we will do, we will check if the popped element has a left or right. If it is a left, then we put the same into stack 1. If it is a right, then we put that also into stack 1. Okay, and what we will do after that, we will make another while call, and for s2 till it is not empty, we will pop everything out, right? And we will print it. So this printing will actually give us our post order traversal, right? So this has been what has been binary tree. We have looked at what is binary tree. We have looked the recursive way of traversing over the binary tree. Then we have looked over the three different traversal iteratively, and these are one of the most frequently asked questions, or the basis of one of the most frequently asked questions in product based companies. So this is very important, and in next lecture we will move towards binary search tree, and we will try to solve some questions related to that. Before we stop the lecture here, do not forget to subscribe to the channel, because if you subscribe you will be getting regular updates of what I am teaching and how can you make yourself better for the product based company interview. Thank you.